we're going to need to be able to graph lines fairly rapidly, make quick sketches of lines. And we're also going to need to be able to determine the equation of a line based on some characteristics of the line, like knowing what the slope of the line is, along with a point that's on the line, or by knowing 2 points that are on the line, what's the equation of the line. So let me remind you of a couple of quick points. And there's multiple ways to see the equation of a line, but one of the methods, and one method that we don't really use very often, would be an equation of the form ax plus by is equal to c. And this is called the general form, or sometimes the standard form. General form of the equation of the line. And in this form, generally the a, b, and c are whole numbers, are integers, positive or negative, but integers. So an example would be 2x plus 3y is equal to 12. That would be a good example of the equation of a line in standard form, or general form. We don't particularly like that form. We need to recognize that it is the equation of a line, and so if we were to graph it, we could quickly get a few points on the line and make a graph easily. Now, the form that we like primarily is called the slope-intercept form, and we recognize then what we're used to seeing there is something of the form y is equal to mx plus b. And this is called the slope-intercept form, and that's what we're primarily used to, slope-intercept form of the equation of a line. We like the y equal to, and remember, the reason that we like this is that we can read the slope of the line and the y-intercept. So the slope of the line is the value m, and that m just represents, in this case, is the coefficient of x. And the thing that we know about the slope is if that slope is positive, then the line is rising. It's going up from left to right. And if that m value is negative, or the slope is negative, then the line is falling, which means it's going down from left to right. So it's nice to know that slope. And of course, the bigger the number, the more steep the line. And the y-intercept we can also read, and it has to do with that constant b, doesn't it? The y-intercept, now y-intercept is a point that is on the y-axis, and so the x value is 0, and the y value is that number b. So for instance, we could have an equation that looked like y is equal to 1/2 x plus 3, and we would know that the slope is 1/2, and the y-intercept, in this case, of course, is 0,3. So it crosses the y-axis at y value of 3, and a slope of 1/2 means it's positive, it's rising, but not real quickly. So I'm sure that you remember those things. Now, there are a few other things that we want to recall. I tell you, I guess let's do this real quickly. Let's take an equation in slope-intercept form and let's graph it. So this will be our first example of something that we'll actually do. Graph, and let's say, let's graph y is equal to negative 2x plus 1. I'm going to do this kind of a real quick sketch. I'm not going to try to be perfect here. But as we recognize, and this is the thing to notice here, as we recognize when we graph this line, we're expecting a line that's going down because the slope is -2, isn't it? So recognizing the slope is -2 tells us we have a decreasing line or a falling line. And we also know real quickly that the y-intercept is the point where x is 0 and y is 1. Now, I'm going to draw freehand coordinate axes here. Let's say there's the y-axis. Whoops, those are supposed to be straight lines. I'm sorry, and there's the x-axis. And we'll let this be 1, 2, 3, 4. And of course, down below we have -1, -2, -3, -4, and of course it continues. And we'll let this be 1, 2, 3, 4, 5, and -1, 2, 3, 4, 5. So I'm going to put in a -2 and a -4 just because it's getting crowded, a +2 and a +4, and that way we can recognize what those other values are. Now we already know that the y-intercept is 0, 1, so it crosses the y-axis right there. And it's a slope of -2, so it's going to be going down to that point, isn't it? But since we know that it's a line, we really just need a couple of points. And we might do more than a couple, but that's really all we need. And so I just make a little solutions table. Now, what we really already have is the x value of 0, and when we look at the equation, if x is 0, then y is -2 times 0 plus 1, which is just 1. And that is that y-intercept. So we might choose an x value of something like 2. And when we do, of course, we calculate y by saying, oh, well, y is -2 times 2 plus 1, and that ends up being -3, doesn't it? So 2, -3 is also a point that is on the line, and that's this point. Now, we have a pretty good idea of what this graph already looks like, but we might try one other value of x. And so we might say, why don't we try x as a value of -1, and when we plug that into the equation, we might be able to do it in our head, but when we plug that into our equation, we see that that is what? 2 plus 1, or 3. So we get a y value of +3 when x is -1. And so that's the point that's about right here. And so we ought to be able to easily sketch that line in, since we know that it represents, it is the equation of a line. Let me get a straight edge here. And freehand, I didn't do too badly, did I? Of course, that line goes forever in either direction. So quickly, we've done it. Again, this is not new information to you, but it's just a reminder of how we do things. Now, we also need to be in a position that we will recognize real quickly how to anticipation, that is, for what the equation of slanted lines look like. And so slanted lines are going to be of the form, just the one we saw, are going to be of the form, or we can write them in the form of y is equal to mx plus b. And the issue here is it has both a y value and an x value. So we have an example that might be y is equal to 3x minus 4. That would be the equation of a slanted line. Now we have a couple of special types of lines, and one of those is a horizontal line. Now, a horizontal line is one in which the slope is 0. See, it's not going up, it's not going down. And on a horizontal line, the slope, which of course is indicated by m, is actually 0. And so we can see, if we look at that above idea, if m is 0, this is just y is equal to. And that's really what we need to recognize, is if we have a horizontal line, it's only going to have one variable in it, and the variable is going to be y. And so we would recognize, if we know that this means we're talking about a line, y equal -4 as an example, that is a horizontal line that goes through the y value of -4. So if here is our x-axis, and here is our y-axis, and here's -1, and here's -2, and here's those are negatives, pardon me, -3, and here's -4, then y equal -4 is the line, the horizontal line that goes through that value. That's the line y equal -4. Now, similarly, vertical lines are also different than slanted lines in the way the equation looks. In a vertical line, just as a reminder, the slope is undefined. Vertical lines we can't represent a vertical line with a slope. But vertical lines are going to be, and I'm sure you recall this, are going to be of a form where we have only one variable, but the variable is x instead of y. So we might see something like x is equal to 2. Well, that represents a vertical line, and it's the vertical line that goes through the x value 2. And again, I'm not trying to teach you this from scratch. I'm expecting you to already know about this, and I'm just reminding you. So x equal 2, if we recognize that it's supposed to be a line, is going to be vertical, means straight up and down, and it goes through the x value 2. So x equal 2 is the line that we've drawn there. Now, we also recognize that we can calculate the slope, and that's something that we want to do, is calculate the slope of a line. Now, in the case that it's written in slope-intercept form, all we have to do is read the slope. But particularly, we're interested in the slope of a line from the graph. So that might be when we don't actually know the equation, we see a graph of the line. So for instance, okay, let me draw a graph here. And I'm just going to sketch one in real quickly, and pardon me for it not being perfectly accurate, but I'm sure that's okay with you. Let's see, there's 1, there's 2, there's 3, there's -1, there's -2, there's -3, there's -4, there's 1, 2, 3, there's 1, -1, -2, -3, and let's see here. Let me, and pardon me, you recognize that is a 1, that is a 2, that is a 3, that's 1, 2, 3, -1, -2, -3, and so on. -1, -2, -3, and so on. And let me sketch in that line, okay? So here's a line that we're talking about. And we want to know the slope. In fact, we can probably figure out what the equation of the line is as well. But let's first worry about what the slope is. And so, looking at the graph, we know we might be able to determine other points that are on the graph, but we know clearly the 2 points that are on the graph. The points, let's see, -2, 0, which is the point to the far left, and 0, 1 are points that are on the graph. Now, if you recall, to calculate the slope of a line when we know a couple of points on the graph, we use the slope formula. So in this case, to calculate the slope, we use the slope formula. Okay, and the slope formula is, well, m represents slope, and the formula for calculating slope is a fraction where in the numerator we have y subscript 2 minus y subscript 1. And in the denominator we have x subscript 2 minus x subscript 1. And what this refers to is that we are using 2 points. See, we're using points, and we need 2 of them, we're using points where one point has an x value of x subscript 1 and a y value of y subscript 1, and the second point, or another point, is x subscript 2, comma, y subscript 2. So all this is really telling us is we take the y value of one point and subtract the y value of the other point for the numerator. And the denominator, we take the corresponding x values. So that means we're taking the x values in the same order. And it really doesn't matter what order we use as long as we do it in the same order. The x and y's, x sub 2 and y sub 2 from the same point, and x sub 1 and y sub 1 from the same point. So in this case, I might say, okay, I'm going to take the y value from this point, that would be 1, and I'm going to subtract the y value from this point, and that would be 0. And then I've got to do the x subtractions in the same order. So that means I start with this x value on the bottom, and I subtract the x value that's over here, and that's negative 2. Now the formula has the subtraction in it, but the x value that I'm subtracting is negative 2. So it looks like 0 subtract negative 2. Well, of course, 1 subtract 0 is 1, and 0 subtract negative 2 is the same thing as 0 plus 2, or just 2. So the slope of this line is 1/2. And of course, we expected it to be positive, and since it's not real steep, 1/2 slope is reasonable. Now, I'm really interested in the next idea. And we could actually take this equation that this graph that we just saw, but what I want to do is I want to think about finding the equation of a line if you know its slope and a point on the line. And we'll have to do this frequently later on, a point on the line. So if you either want to pause here's the idea. So in this example, we're going to say find the equation. So this is an example that we're looking at. Find the equation of the line with slope 1/2 that goes through the point negative 2, 0. Now, if you look back at the old, if you in this video, you go backwards and look at the graph we just had, well, we determined the slope was 1/2, and it does go through the point negative 2, 0, doesn't it? So we're really finding the equation of that line that I drew. But we don't really need to know that. We can just use this information that we're dealing with here. Now, there's two possibilities. And one, let's do it this way. One, we could use the idea that all equations of lines can be written in slope-intercept form. So we could just use that idea. And we, from the information that we have, we already know that the slope is 1/2. So that tells us our equation has to, in fact, look like y is equal to 1/2 x plus b. And so the only piece that we need to deal with is to determine what b is. Well, the way we determine what b is that we know a point that is on the line. We know a point that's on the line. Now, knowing that, remember that's an x value and that's a y value. And for a point to be on a graph, whether it's a line or any other kind of graph, it means the y value and the y value of that point make the equation that's being graphed true. So it means when you put that x and y value in, the equation of the graph is in fact true. Well, if we put the y value of 0 in here, and if we put the x value, the x value of -2 in here, then that means the equation that we get has to be true. And so what this allows us to do is that we've got to decide what b is for this equation to be true. Otherwise, that point wouldn't be on the line. Now, we can do this pretty easily here, because on this side we have 0. 1/2 times -2 is -1. And so all we need to do here is add 1 to both sides of this equation so that we can solve for b. That's really what we're doing. And we end up with 1 is equal to b. And so taking the information from the slope and the information we just gathered, we know that y equal 1/2 x plus b, b being 1, is the equation of the said line, the described line. So here we have the equation of it. Now, a second technique that works just as well is one in which we use what's called the point slope form, or sometimes I call it the point slope formula. And I'm going to call it formula, although our book would call it form. And the point slope formula says, okay, the equation of a line can be written in this form. Y subtract y subscript 1 is equal to m slope times, in parentheses, x subtract x subscript 1. Now, the regular x and y are the x and y in the equation. The y subscript 1 and the x subscript 1 represent a point that is on the line, and the m, of course, is the slope. So this requires, to use it, it requires the slope and a point that's on the line. Well, we have that information. Above, we have a point that's on the line. See, our point is -2, 0. And so that's the x value, the x sub 1 of the point that's on the line, and that's the y sub 1, the y value that's on the line. And of course, we know from above, we were told the slope is 1/2. So our y sub 1 is the y value of the point that we know is on the line. So this reads y minus 0 is equal to our slope, which is 1/2, times x minus the x value we know that's on the line, of a point that's on the line. So x subtracts our x value of -2. And of course, the left side becomes just y, and the right side is 1/2 times x plus 2, minus -2 is plus 2, isn't it? And then when we distribute that 1/2, we have 1/2 times x plus 1/2 times 2, which is a 1. We get the equation of that line in a little different form. I mean, it's the same form, but we approached it a little differently.